This illustration deals with grounding separately derived systems, AC, alternating current type systems, in accordance with 250.30 A6 exception to A1 and B. Now, the purpose of the change, this new exception has been added mainly to clarify that if only a rod, pipe, or pipe electrodes, concrete encased electrodes, or ground rings are present and used, the size of the common grounding electrode conductor shall not be required to be any larger conductor than required for the rod, pipe, or pipe electrodes, or concrete encased electrodes or ground rings that are present. Now notice what this is calling for now, if that's all that's present. So looking at the illustration, we have 3 transformers, as you see in the illustration, connected to a common grounding electrode conductor, as you see up there. And if we reviewed now the common grounding electrode conductor, now where separately derived systems are involved, so those transformers, as you see above, are fed from the service equipment, usually in most cases. And then notice the electrodes, though, common grounding electrodes shall be a metal structure frame, or it could be just a grounding electrode conductor, as outlined in 250.30 A6 A2. Or you could look at 250.68 C as in car 1, and you have the 2 main sections that deal with the subject. Now, first of all, let's just kind of take a look at this driven rod. It's at the bottom of the illustration, and it's titled, call out, driven rod or plate, 250.66A, and that's number 6. As you can see, that's the size of the grounding electrode conductor connected to that common grounding electrode conductor. Next, let's take a look at the concrete encased electrode, CEE, 250.52A3, and it's a number 4, connected to that rebar at a 1/2 inch in diameter, 20 foot in length, or spliced together to create such a length. It's a lot of people calls it the old Ufer ground, you know. Now, let's take a look third at this ring that's encircling the building. And it's a number 2, and your conductor is number 2. Now number, I shouldn't say number, but fourthly, I'd like to take a look and notice that the largest of all these that you see here, all 3 of them, is number 2, so you could have a number 2 common grounding electrode conductor there, or you could just make it 3/0 by 250.60 or 250.68 C1, you know, however you wanted to do that. But you want to review your notes very carefully here, because they give you the main impact of this new exception. Now notice note 1, if a common grounding electrode conductor is a conductor, it must be at least a 3/0 conductor if you do it by 250.30A6A1. Note 2, metal water piping or metal structure frame can be used as a common grounding electrode conductor. Now, that note 1, you know, being cases where you had a metal water pipe or structural steel, and table 250.66 size that grounding electrode conductor, then you know it never has to be larger, that common ground electrode conductor, than 3/0 by that section. So that's not conflicting here. Notice that all we have here is 250.66 A, B, and C electrodes. We don't have metal water pipe or structural steel involved in this illustration and this revision. They want to make sure that this new exception would let you size things that you could terminate for the grounding electrode common, or these other electrodes that you could terminate it. You know, that's a very important thing. So keep that in mind. And then, as you know, the grounding electrode conductor from transformer number 1 to the left, you have 4 conductors that are tapped from the secondary side, which the code calls transformer secondary conductors. There are 4 alts, so you'd need number 2 to this number 2 here, see? And then you just go in and do otherwise. You'd say, well, I have 4 alt secondary conductors tapped and transformer in the center, then number 4. And over here you say, well, I have 1 alt conductors tapped there, then that'd be number 6. But you see, number 2 handles it all. And that's what they were trying to point out here with this new exception.